Let's move on to question 3C from the section 8.1 homework. And for question 3C, I need to continue solving for the right angle triangle, starting with angle P. So P is right here, and we're given 54 degrees, and we know this angle is worth 90 degrees. So we can definitely find P using the concept of angles in a triangle adding up to 180 degrees. So in order to find angle P, I take 180 degrees and I take away the 90 degrees and then I take away the 54 degrees. And after I do that, you should be left with 36 degrees. So angle P has a value of 36 degrees. Okay, let's move on to X now. Now X is a side. So take a look at X and look at what you're given in the problem. You're given this 54 degrees and you're also given this 12. So the 12 is the hypotenuse in this problem. It's directly across from the 90-degree box. So 12 is the hypotenuse. And since X is right next to the 54 degrees, this is your adjacent. All right, so which trig ratio uses the adjacent and the hypotenuse? Well, that would be the cos angle. All right, so cos uses the adjacent and the hypotenuse. So in order to set the ratio here, it'd be cos of the angle, so cos of 54 degrees, and that's going to equal to the adjacent, which is x, so x divided by the hypotenuse, which is 12. All right, now we need to solve this particular equation here, and all you have to do is, in order to solve for x here, you can just move the 12, and since it's on the bottom, you're dividing, so in order to get rid of that, you would multiply it on to the other side. So it'd be 12 times cos of 54 degrees, and that equals to x. And then from here on, you can go to your calculator, and your calculator can finish off this calculation for you. So on your calculator, you would just input 12 times cos of 54 degrees. And remember, for this problem, you're rounding to one decimal place, so the answer would be 7.1. All right, so 7.1 equals to x. Okay, so x has a value of 7.1. Okay, let's erase that, and then we will go and finish out the rest of the problem. Okay, the last part of this problem is I need to find side y. So if I take a look at the y here, I still have the 12 as a hypotenuse, and I still have this 54 degrees. So with respect to y, with respect to the 54 degrees, the y is the opposite, right? All right, so now you need to consider the opposite and the hypotenuse, and which trig function uses the opposite and the hypotenuse. So that would be the sine function, right? Sine uses opposite and hypotenuse. So in order to set the ratio, it would be sine of the angle, so sine of 54 degrees, and that would equal to the opposite. The opposite is y, and the hypotenuse is 12. So sine 54 degrees equals to y divided by 12. And just like the previous problem, you can get rid of the 12 by multiplying the left-hand side by 12. So it'd be 12 times sine of 54 degrees, and that equals to y. All right, and then from there, you can also go to your calculator, and I'll do one more calculator step here. Erase that, so it'd be 12 times sine of 54 degrees, and that gives you a 9.708. So round it to one decimal place, that would be 9.7. So 9.7 would equal to y. Okay, so y has a value of 9.7. Okay, that's it for 3C. Let's move on to 3D now. Okay, so for 3D, the very first thing I need to do is I need to find angle A. So look at angle A. What are you given? Well, I see an 11 here and a 4 there. So the 11 is on the other side of the 90-degree box. So this is your hypotenuse. And since 4 is on the opposite side of that angle A, this is your opposite. So which trig function uses the opposite and the hypotenuse? Well, that would be the sine function, right? Sine uses the opposite and the hypotenuse. Now, in order to set the ratio, it would be sine of the angle, and since we're not given the value of that angle, we can use the letter, which is sine A, and that would equal to the opposite, which is 4, and then we divide that by the hypotenuse, which is 11. All right, so that's how you would set the ratio. Sine of angle A is 4 over 11, and in order to solve for angle A, you're taking the inverse of each side. So that's going to look like this. It's going to be sine of the inverse, and then 4 over 11. So essentially you're going to your calculator to do this, and anytime you're looking for the angle, you're always using the inverse function of that angle. Okay, so how do I input this into my calculator here? Okay, so since I'm looking for the angle, I need the inverse function. So you hit the second option and then hit sine, and you should see the sine to the power -1, and then just input 4 divided by 11. And then if you do that, you should get 21.32, and to one decimal place, that is 21.3 degrees. So then A would equal to 21.3 degrees. Sorry, 21.3 degrees. Okay, that's it for angle A. Let's move on to the next one, and the next one here is I need to find the theta angle, which is this green angle right there. All right, so let's look at what we're given here. We're given the 4 and the 11. So if I go straight across from the 90-degree box, this is your hypotenuse. And since 4 is right next to theta here, this is your adjacent, right? So one thing that you have to do in the homework problems for section 8.1 is that you need to be able to find the adjacent, hypotenuse, and opposite quickly. All right, so which trig function uses the adjacent and the hypotenuse? Well, it's cos of the angle. So cos uses the adjacent and the hypotenuse. Now to set the ratio here, it'd be cos of the angle, which is cos theta, and that's going to equal to the adjacent, which is 4, and the hypotenuse, which is 11. And from here, you would isolate for the angle by taking the inverse of each side. So this would be cos of the inverse of 4 over 11. And then from here, you just go to your calculator one more time. So let me clear this. So I would hit second cos to activate the inverse function, and then I would input 4 divided by 11. And if I do that, I get 68.67. So rounded to one decimal place, that's going to be, once again, it's going to be 68.7 degrees here. So 68.7 degrees. So this would be 68.7 degrees. And that's it for angle theta. Okay, and the last thing that we have to do here is I need to find the value of x here. I can definitely use a SOHCAHTOA ratio here, but you know, I'm given the 4 here and I'm given 11, and we can also use the Pythagorean theorem here because it's a right angle triangle here. So using the concept of the Pythagorean theorem, right, we just got to find the values of A, B, and C here. A and B, these represent the legs of the triangle, and C represents the hypotenuse, right? So since the hypotenuse is 11, we can write this as 11 squared for C, and then this could be 4 squared plus x squared, and then we just solve for x here. So this will be 16 plus x squared equals to 121, and x squared would equal to 121 minus 16, and then x squared would equal to 121 minus 16, which is going to be 105. So now when we have x squared equals to 105, we can just take the square root of both sides. And on your calculator, the square root of 105 is going to be 10.2. So 10.2 is the value for x. So x has a value of 10.2. So the 10 didn't come out very good here. Sorry, it's actually very difficult to write with this pen here today. Okay, so that's it for that particular question, and now let's move on to letter F. Let's move to letter F here. Okay, so letter F is very similar to the problem that we just solved. The very first question is I need to find angle A. So what are we given here? We're given a 7 and a 5. So with respect to angle A, 5 is your opposite, and 7 here is your hypotenuse. Okay, so which trig function uses the opposite and the hypotenuse? Well, that will be the sine function, right? Sine uses opposite and the hypotenuse. Okay, so setting up my sine ratio would be sine of angle A, so sine A, and that would equal to the opposite, which is going to be 5, divided by the hypotenuse, and that's going to be 7. And from here, you would just go to your graphing calculator or any calculator device and find angle A. So angle A is really the inverse of 5 over 7. So this is very similar to the previous problem. And let me just tell you the final answer instead of just bringing up my calculator here. It would be 45.6 degrees. So angle A has a value of 45.6 degrees. Okay, and then after that, we got to find angle B. Now, angle B is not too bad once you find angle A. So for angle B, we can use the concept of angles in a triangle add to 180 degrees. So we know that the triangle adds to 180 degrees. We can take away this 90, which is 90 degrees, and we can also minus angle A, which is 45.6 degrees. And if I go ahead and subtract those numbers, I get 44.4 degrees. So angle B has a value of 44.4 degrees. Okay, and finally, let's move on to the very last question here, and that's I need to find the value of x. So there's x. So so for value x, I can definitely use the Pythagorean Theorem here, but I will just approach this a slightly different way here, just so that you have more tools to solve these kind of problems. Let's just assume that angle B here, we just solved for angle B. Let's just assume angle B is what we found, which is 44.4 degrees. Now, if I look at angle B, x is your opposite, right? And if I go across here, this 7 is your hypotenuse. All right, so I can use a trig ratio to solve for side x instead of using the Pythagorean theorem, which I did in my previous problem. So let me just show you how you can use a trig ratio to solve for the missing side there. So since I have the hypotenuse and the opposite, I'm using sine of the angle, and that's going to be 44.4 degrees. So remember, sine uses the ratio of the opposite and the hypotenuse. So the opposite is going to be x, the hypotenuse is going to be 7, and now I can solve for angle x by taking the 7 and multiplying it with the sine 44.4 degrees. So in order to do that, I would write the 7 multiplied by the sine of 44.4 degrees, and that equals to x. And if you go ahead and put that in your calculator, you should get an answer that's very close to 4.9. So 4.9 is the value of x.